Hello friends, I am Professor Chaitanya Deshpande. In previous video lecture, we have seen derivation of short circuit admittance parameter. So in this lecture, we will study derivation of transmission parameter, which is also called as ABCD parameter. So here you can see the diagram of transmission parameter. The transmission parameter is also called as ABCD parameter, or it is also called as chain parameter. So you will get a transmission parameter when voltage and current at input port is represented in terms of voltage and current at output port. So this is what equation number 1 is nothing but V1 equal to A V2 minus BI2 and I1 equal to C V2 minus DI2. So you have to consider one point is that here negative sign is given to the I2 and not for the parameter B and D, because it is assumed that the output current is coming out from the network. So we all know that when current is coming out from the network, in KCL, we have studied this sign convention that if the current is moving away from the node, it is considered to be negative, and if the current is moving towards the node, it is considered to be positive. So same case we have applied here, that if the current is moving away from the network, we have considered it as a negative. So one thing you have to remember is that this minus sign is given to the direction of current, not to the B and D. So when do we get this A, B, C and D? So there are again two cases. If you see equation number 1, if you want to have these two parameters A and C, you need to put I2 equal to 0. That is, case number 1 will be what? It is when output port is open circuited. So when the output port is open circuited, you will get these two parameters A and C. So here you can find case number 1 is when output port is open circuited, I2 equal to 0. So A equal to V1 by V2. So this is called as reverse voltage gain with output port open circuited. Similarly, C equal to I1 upon V2 when I2 equal to 0. So I by V is nothing but what? It is admittance. So you can see the name of this, transfer admittance with output port open circuited. So case number 1 was when output port is open circuited. For getting the parameters B and D, if you see equation number 1, if you want parameters B and D, this voltage should be equal to 0. So when do we get voltage equal to 0? When we short circuit that particular branch. So as it is suffixed to here, you can see case number 2 is when output port is short circuited, that is V2 equal to 0. So you will get B equal to minus V1 by I2 at V2 equal to 0. So this B is nothing but, we know the ratio of V by I is impedance, so its name will be transfer impedance with output port short circuited, and D equal to minus I1 by I2 with V2 equal to 0. So where D equal to reverse current gain with output port is short circuited. Then again there are condition of reciprocity and condition of symmetry. So we have seen definition of reciprocity, that a network is said to be reciprocal if the ratio of excitation to the response will remain same even if we interchange the position of excitation and response. So you can see the figure here. Here voltage Vs is applied to the input port and output port is short circuited. So all the input port parameters are denoted with suffix 1 and all the output port parameters are denoted with suffix 2. So here V1 equal to Vs, V2 equal to 0, and as the direction of both currents on the output side, I2 and I2 dash are different, so we will write here I2 dash is equal to minus I2. You have to put this equation number 7 in the original equation of ABCD parameter, that is equation number 1. This equation V1 equal to A V2 minus BI2, I1 equal to C V2 minus DI2. So if you put this equation number 7 in original equation, you would get Vs equal to minus B into minus I2 dash, that is B equal to I2 dash, and I1 equal to minus D into minus I2 dash, that is D into I2 dash. Our aim is to find out ratio of excitation to the response. So here excitation is Vs and that of response is I2 dash. So if you see here, Vs upon I2 dash will be equal to B. So this will be equation number 8. In second case, we are going to interchange the position of excitation and response. So when Vs is applied at the output port and input port is short circuited, as input port is short circuited, obviously V1 will be equal to 0. The direction of currents at input port are opposite, so I1 will be equal to minus I1 dash, V2 will be equal to supply voltage Vs, and I2 will remain as it is I2. So again, if we substitute this equation 9 in original equation of ABCD parameter, we would get equation number 10 as 0 equal to A Vs minus BI2 and minus I1 dash equal to C Vs minus DI2. We have to find out ratio of excitation to the response, means Vs upon I1 dash. If you see this equation number 10, the second part of equation number 10 is minus I1 dash equal to CVS minus dI2. So we have to remove I2 term from this equation. So we can easily remove our I2 term from this equation by using first equation of 10th equation. We can say that 10A. So I2 will be equal to A by B into Bs. If you substitute this, you will get a ratio like this, that Bs upon I1 dash equal to minus B upon Bc minus AD. According to the condition of reciprocity here, the ratio of input to the output or the ratio of excitation to the response will remain same if we interchange the position of excitation at response. So here you would find that Vs upon I2 dash equal to Vs upon I1 dash. So this relation is extremely important from any MCQ point of view. AD minus BC is equal to 1. Next point is condition of symmetry, and we all know the definition of symmetrical network, that if the ratio of voltage to the current remains same when one of the port is open circuited or open circuited or short circuited. So for this condition of symmetry we have used this particular diagram, and for case 2 we have used this particular diagram. So when output port is open circuited, obviously I2 will be equal to 0 and we will get Vs equal to AV2 and I1 equal to CV2. So if you take a ratio of voltage to the current at one port, so Vs upon I1 is nothing but ratio of voltage to the current at input port, which is A by C. In second case, when the input port is open circuited, that is I1 equal to 0, C into Vs equal to dI2. So from this we will get Vs upon I2 equal to D by C. So for network to be symmetrical, we know the definition. As per the definition of symmetrical network, the ratio of voltage to the current should be same if one of the ports is either open circuited or short circuited. So A equal to D will be the condition of symmetry. Thank you very much for watching this video.